Good morning, algebra students. We are going to be looking at 8.5 and 8.6 pretty much to finish up our year. Just a little information about the rest of the year. I'm going to give you some lessons and work to do through next week. And then the final week, we only have 3 days. I want that to be a week where you can just finish turning in stuff to me and just doing missing work, because everything has to be into me by May 28th. So the high school teachers always stress to me how important factoring is, how they want you to understand it and do well with it before coming to the high school. So this is a perfect way to end out the year. 8.5 and 8.6 deal with factoring. So in today's/tomorrow's assignment, it is only going to be about example 1 right here. And what I'm going to do on paper is I'm going to work through A and B here. I think it might be a little confusing the way they show work here, so I'm going to do it on paper with you too. And then I'm also going to show you how to work through and get these 2 guided practice questions, okay? And then your homework for this lesson will only be on example 1. And then Monday next week, I am going to explain to you example 2 and 3. They're definitely trickier, and so I wanted to kind of break these 2 up so you could feel confident about this before moving on to something a little different, okay? So factoring is pretty much the exact opposite of distributing, which you were doing earlier in chapter 8. So you're going to see when we go over these that you're actually going to be distributing to check all of your answers. So all of your answers, you will be able to check to make sure you are good to go before you move on. All right, so the first example, again, like I said, they're on page 494. I'm just using those 4 problems there. So you're going to be given a polynomial, and you need to find, it's all about greatest common factor. You want to factor out the greatest common factor that you see in all the terms. So, focusing on the coefficients here, the numbers here, the greatest common factor of 27 and 18 would be 9. And then you also have to look over at the y's. The greatest thing you could factor out, you can factor out a y to the first. They both have a y to the first as their greatest y variable. So you can pull out a 9 and a y. So what that's going to look like then, so see how I could factor out a 9y from both of them. And then what's left over is it's pretty much just like you dividing each of those terms by 9y. So you would have a 3y left over from the first part, and then you'd only have 2 left over from this one when you factored out the 9y. So I think it'll make more sense to you if I then go, and like I said, to check these, you should be able to go take this problem. It should look, this looks similar to what you were doing earlier in chapter 8. You should be able to go distribute back out the 9y just to check. So again, this is us checking. Okay, so 9y times 3y, that would make 27y squared, right? Because we have 9 times 3, and then y times y. And then you can do 9y times 2. And that would make a positive 18y. So see how that gave us back the original problem. So again, the answer is what I circled, but you can check it by going and distributing. And I would like to see that. I want to make sure that you all are checking by distributing before you're done, okay? It only takes a second to do, and it really helps to make sure you're on the right track. All right, then one of the guided practice ones they gave you at the bottom of page 494 was this one. It's a pretty simple one that I just wanted to work through with you to show you how simple they can be. So one of the terms has a W, the other one has a V, so you obviously can't factor out a variable on this one because they don't have any variables in common. But you do have a greatest common factor of 15 and 3, which would be 3, so you're going to factor out that 3. And then, so factoring out that 3, that means just dividing out 3 from both of those terms. You'll still have a 5. I messed up on that, sorry. There. You'll still have a 5W, and then when you factored out that 3 over here, you'll just have a minus V, because up here it was minus 3V. So again, just real quick, just to go, even if you do it mentally for one simple as this, if you want and factored back out the 3, or sorry, distributed back out the 3, you'd have 15W, and then 3 times negative V would be minus 3V. So again, that was the way you checked. Always circle your answer. This is the answer to factoring, okay? All right, and then the last two I have for you are a little bit lengthier here. This is the one that they did work out for you in your book. So here, let me cover that up for a second. So just studying the 3 terms on this polynomial, so you're going to check out all the numbers there. I have a -4, a -8, a +2. The greatest common factor of all 3 of those would be 2. And then if you look, all 3 of those terms have the greatest would be just a to the first and b to the first. If they all had all had b squared in them, you could have factored out a b squared, but they don't all share that. So the greatest thing you can take out from all 3 of those would be 2ab. And then for each one of those terms, like I said, it's just like to figure out what goes in here. It's just like dividing each of these by 2ab. So if you did that, wouldn't you have a -2 left for the first term? And then you already pulled out an a, but you still have an a left because it was a squared. And then you factored out the b, so you can't put a b here. And then next, when you factor out the 2ab from this, you are going to have a negative, so put minus. And that would be 4. You already factored out the a to the first, but you do still have a b left because this was b squared. And then, so the one thing, reason specifically why I wanted to do this one was for this last part. 2ab, you factored out that whole 2ab. So I know you might just be thinking, I don't need to write anything here. But think about that. When we go and check, if we don't write anything here, are you going to end up with a 2ab term at the end? You wouldn't. So what you have to put is +1. Okay, so now you will then have, if you go distribute to check, you would at the end be doing 2ab when you go out and do the 2ab times 1, you'll end up with 2ab, okay? So again, just to check, I want you to get in the habit of doing the checking process. Okay, so when you're done, circle the answer you want, but still you can do the check here at the bottom. So for the first term, you'd have 2 times -2, a times a, and then you just have a b, and then check the first term. Yep, it matches. And then you can do 2ab times -4b, so you'd have -8. That would make a and then b squared because you have b times b. And then lastly, that's what I was talking to you about, the 2ab times 1 will just make 2ab. And always make sure that this matches the problem at the top, okay? But again, this is your answer. The factoring you did is the answer. Okay, then the last one I wanted to show you is similar to C. So you don't always have to factor out a number. Sometimes the greatest common factor is just going to be 1. So for example, the numbers here, I see a 7, a 21, and then there's nothing here, so we know that there's a 1 here, right? So the greatest common factor is not 7, because 7 isn't shared here, is it? So for this one, the greatest common factor is just going to be 1. So next, let's just go focus on the variables, the letters here. So the greatest U and T variables we see will just be U to the first and T to the first. Okay, so all we can factor out is a U, T. So go divide each of those terms by UT, and whatever's left goes into the parentheses here. So we would still, for the first term, we'd have 7, and we'd have a U to the first and a T to the first. And then here we'd still have 21 for the coefficient, and factoring out a U would not have a U here then, but we still would have a T to the first. And then lastly, here it is again. Oops. Factoring out the UT, you know, we can't just put 0 here or nothing here, even though we feel like there's nothing left, right? But we still have to put, it'll be a -1 because it's minus UT. Because then when we go check by distributing out the UT, we'd have 7, and it would be U squared T squared, because we have U times U, T times T. And then again, we'd have plus 21, then it'd be just be U, and then T times T would be T squared. And lastly, see how this is important, because when we do UT times a -1, we'd have a minus UT, and that is needed, right? So this was our check. Again, when you do these, show that. You can even just write check there and circle this part of your answer. Okay, so all of your problems today will be like those. I'll just put this on Google Classroom right now. Homework, I want you to do 1 through 4 on page 497, and then 15 through 20 on page 498. Any that you come across from these 10 problems, you know, if you want to send me 1 or 2, I can go and make another quick video and just work through them with you if needed. Good luck.